Hello, it's Connor, back with another devlog for PlaneTech. Today we'll be looking a bit more in depth at our mesh generation, which is not currently included in the UI tool shown last week. First, you'll see several options on the right-hand side for the mesh generator, including the radius of the planet as well as the scale factors for X, Z, and Y, since Godot uses XY for the standard screen space. This means that we'll need to use XZ for the longitudinal and latitudinal positions on the map, and Y for the height of the terrain. When we generate the mesh, we use these values to scale the map to the desired size. For this demo, we actually shrink it so we don't have to worry about the camera culling any detail that's too far away. And at a glance, it may look like these, sorry, I forgot to enable both of them. Let me rerun that. At a glance, and I forgot to reset that one. Okay, here we go. This time for real. At a glance, it may look like these images or these meshes are simply images, and that's because we color the vertices of the mesh according to the source image. However, these are full meshes, and we're currently generating two of them to showcase two options for the display. The left-hand image is generating a vertex for each pixel, while the right-hand image is actually generating a vertex between each pixel. The difference in these approaches is minimal, but the right-hand mesh averages the surrounding pixels for each vertex and provides a slightly smoother look. Additionally, you'll notice that the generation time took significantly longer than the goal for this library. It actually was pretty close because we've already implemented some of the optimizations into this version. This is because at the moment we're fully processing the 1024 by 1024 images twice, meaning we're generating roughly 4.2 million vertices per image. Again, this actually isn't the case anymore since we already have a couple in. It turns out that working with the full-scale images is really frustrating even when you're doing it as a demonstration, so I went ahead and surfaced a couple of these things just so I'm not pulling my hair out while I do this. But imagine that this said 4.2 million triangles being drawn instead of 16.3 thousand. We'll come back to the optimization just a little bit, but now let's look at how we can take these and make them proper planets. So if we come in here, and I'll use this one since it's out just a little bit, and I'll check this project to sphere, and I'll use the same resolution, and I'll make the radius say 5 units. And now when we run it, oops, I forgot that we need direct pixel to map as well, just because I'm using a pared down version of the library here for the demonstrations and for integrating with tiny fights. So the offset pixels can't be projected to a sphere yet in this version of the code. So now that we have that fixed, you'll see we have the planet here. You can also see this very harsh seam. There is just actually a seam there because, again, I'm using a cut down version of the library, and the edge stitching isn't complete on this one, as well as this is not an equirectangular map. So let's go ahead and switch it over to our project map, and let's run that. And now you can see the actual planet. You may notice that this is the South Pole. That's because Godot interprets images from the top to the bottom, and so when we're building the mesh, it reverses it to where the top of the planet is the bottom of the image. This is just another little detail thing that doesn't really impact performance or the code. And you'll notice that it throws a lot of errors in the debugger. Again, that's because the edge stitching isn't fully implemented in this version. So if you've got a good memory now, you may remember that we are planning to use submaps for each pixel, meaning there will be significantly more playable space at the poles than is represented on a sphere. This is because if we regenerate this really quickly, the map, when it's wrapped, all of this space goes into a very small area at the pole. Now, For the scope of the project, it won't really be very noticeable. The only thing that will make it apparent is if you travel to the poles, you can be right at the North Pole and you will still have to go fully the distance of the equator to get around the pole. Now, if you just turn north and step over the pole, we use a little bit of teleporting magic on the player to spin them around without noticing, and you're halfway across the planet. So we would like to fix that up some, but it makes the math and logic a lot more complicated. So for future versions of the library, it's something that we would like to address. However, we're more focused on getting a working project or product out. So these little details we're leaving for later. And for this project, the poles are planned to be very inhospitable, and you probably don't want to be spending very much time there anyways. So finally, you may ask why we're working in Engine, doing real-time mesh generation using scripts. And we think it's kind of key to being able to optimize our libraries moving forward, because it makes sure that we understand and we know every step of the process and every single thing that's happening in our code, rather than relying on external libraries or being locked into specific assets that are generated and take up a lot of space on disk. So we'll take a small look at optimization really quickly, and you'll notice that I have the pixels per step exposed. This is a very, very simple optimization. Basically, it's just when we're processing the image, how many pixels do we skip between each step? So you can see skipping 15 pixels per step, you don't really lose very much detail at this scale. And that's kind of what we're hoping for, because you'll never be able to see the whole planet at 100% detail, right? Like if you go into space today and you look back at Earth, at most you can see 50% of the planet. The backside of the planet doesn't need to be generated at all. We still will be generating it at a very low resolution, but it doesn't need to be there. And this allows us to do significantly faster meshing, so we can adjust the level of detail dynamically during gameplay without impacting other systems. And that's all I have for you this week, but tune in next week when we should be going over some of the cell generation and perhaps adding a small flight sim